Have you ever wanted to make your own custom distro plate, but you thought you needed a CNC to make it happen? Well, I've got good news. Thanks to PCBWay, you don't need one. In today's video, I'm going to show you how I designed this custom D5 distro plate and walk you through everything you need to know to create your own custom design from scratch. Then I'll show you just how easy it is to have it manufactured by PCBWay, who's also the sponsor of today's video. Whether you need a custom distro plate machined, something laser cuts out of carbon fiber, a 3D printed part for your next PC mod, or a custom PCB manufactured, PCBWay has got you covered. With great prices, amazing customer service and super fast turnaround times. And right now PCBWay is running their 8th project design contest with awesome prizes up for grabs, and even if you just participate, you'll still get a prize. So don't miss out, entries close the end of January 2026. So the days of being limited by the tools you own are long gone. With PCBWay you can bring any project to life. Check out their website using the link in the description to see what they can do for you. Now before we jump into CAD and start designing our distro plates, we first need to talk about the O-rings. Now for the O-rings I use this nitrile rubber O-ring cord. Now you can go and buy fixed length closed loop O-rings, but I just found it's much easier to make your own O-rings with this O-ring cord and some super glue. Now the most important thing about the O-ring cord is its diameter, because that determines the size of the groove around the channel in order to get a good seal between the two parts. Now typically I use 2mm O-ring cord, but you can use anything between 1.5 and 3mm, it all depends on your design. Now for this video I'm going to use 2mm for all of my designs. Now before you start designing, please measure your O-ring cord first, because in the past I've ordered 2mm O-ring cord and its actual size was closer to 1.7mm, and that can drastically affect your design. If you want to add a pump, you're going to need O-rings for that as well. Now the DDC pump already comes with its own O-rings embedded into the pump housing. If you get a D5 pump, then usually they come with their own O-rings, but I tend not to use those. I like to use my own O-rings where I have the exact dimensions for it. But more on this later on. Now with all that covered, let's jump into CAD and start designing. The first example will be a basic distro with 2 channels. I just want to illustrate the basic dimensions for the channel and the O-ring groove. And by the way, this isn't a CAD tutorial, it's a design tutorial. I'm only going to show you the minimum allowable dimensions that will work for designing a distro plate. Now I'll be using SolidWorks for this demonstration, but what I'm going to show you will be applicable on any design program. Okay, let's start with the base plate that will have all of the channels cut into it, and we'll make it 100 by 160 millimeters. Now the base plate will be made out of 10mm thick acrylic. Now 10mm is the minimum I'll recommend, but you can go and make it thicker as well. Now I usually make my channels the same size as the tapping drill for a G1/4 inch port. That's 11.8mm in diameter. That's about as small as you want to go, but you can definitely make the channels larger. I'll show you an example of that a bit later. Now the channel depth can be anywhere between 5 and 8mm. Since we're using 10mm plates, I won't go deeper than 6mm. You want to leave enough material so it doesn't crack. For the O-ring groove, I usually start about 1.5mm away from the edge of the channel. If you're tight on space, you can go as close as 1mm. Now like I said, I'm using 2mm O-ring for this design, so the groove should be around 2.2 and 2.4mm wide. I like to go with 2.2mm because when you make your own O-rings, they can stretch a little, and that can reduce the thickness of the O-ring cord. And the 2.2mm width helps compensate for that. And I always make the depth of the groove 1.3mm. Now let's move on to fastening everything together. For this I always use M4 countersink screws. I usually offset the screws about 5mm away from the edge of the O-ring groove. I don't actually model the threads, just the tapping drill size. PCBWay recommends modeling only the tapping drill holes and then specifying the threaded areas on a drawing. Now for the M4 screws, the tapping drill size is 3.3mm in diameter and I'll make the holes 8mm deep. That gives you around 6mm of thread engagement to work with. Now the spacing between each screw hole can be anywhere from 30 to 40mm. I usually just adjust the number of holes until it looks right visually. Now that we've covered the basic channel dimensions, let's talk about the size constraints. Say you want to place the channel right near the edge with the least amount of material around it. From my experience and based on the O-ring groove dimensions we are using, the closest you can safely position the channel is about 20mm from the center to the edge. That leaves enough material for the screw holes. The minimum distance between the edge and the center of the screw hole should be around 5mm, and in this setup we're just above that. Even if your O-ring groove was about 2.4mm wide, you still be fine. So as a rule of thumb, I always keep to 20mm minimum distance between this channel and the edge. Now the next thing I want to show you before we move on to finishing the distro is the minimum distance between the two channels. Now let's draw a second channel and make it a little bit more interesting, but with the same basic dimensions. So you want the channel close enough so that I can actually share the same fixing bolts. In this case, that's about 29.2mm apart. For doing it this way, this bottom section will share the same fixing points instead of drilling two separate sets. I'll then align the hole spacing to match the bottom channel, and then you're basically done with the base plate and we can move on to the lid. For the lid, we'll be using 5mm thick acrylic. 5mm is pretty much the minimum. You want just enough thickness for the G 1/4 inch threads, and 5mm usually works perfect. Now let's add the inlet and outlet ports for each channel. Now like I mentioned earlier, these are 11.8mm in diameter, and we're only modeling the drill size, not the actual threads. I will be showing you how to mark the thread sizes properly on a drawing in the final example. Now if you're planning on tapping the threads by hand, it's usually easier to drill the hole slightly smaller, around 11.5mm instead of 11.8mm. With the ports done, we just need to copy the fixture holes onto the top plate. These holes won't be tapped, they just need to be large enough for the M4 screws to pass through freely, so we'll make them 4.1mm in diameter. Since we're using flush countersunk screws, we also add a chamfer to the top edges. About 2.2mm usually works really well. And then you're basically done with a very simple design of a distro plate. Now to move on to the next example, where we'll complicate the design a little bit more by adding a pump. There are two main types of pumps you can use, a DDC pump or a D5 pump. For this example, I'm going to show you the basic dimensions for adding a DDC pump to your distro plate. Now let's start by creating the base plate that will hold the pump. Let's make it 120 by 120mm, and it's going to be made out of 10mm thick acrylic. Now the next step is to cut a cavity for the impeller. For a standard DDC pump, the cavity should be 42mm in diameter and 7.5mm deep. And you can add a small 0.5mm fillet to the inside edge if you like. It's optional, but it helps smooth things out when machining. Next, we need to add mounting holes to secure the pump to the plate. The mounting dimensions are standard for all DDC pumps. It's 4 M4 screws spaced 50 by 50mm around the center. And the holes should be 3.3mm to a depth of 8mm, which will give us about 6mm of usable thread. Now the next step is to add the inlet and outlet for the pump cavity. The inlet port should be 8mm in diameter, positioned right in the center of the cavity, and it needs to go all the way through the plate. Now let's add the outlet. Before placing it, we need to think about how the fluid flows through the pump. Looking at the plate from this side, we're viewing the pump from behind. The impeller spins clockwise. If we flip the plate around, we're now seeing the pump from the top, where the impeller rotates counterclockwise. Now this means that the fluid enters through the inlet ports and spins in this direction and needs to exit the cavity in a counterclockwise motion. So we'll place the outlet here, facing downwards like this. Now usually I make the outlet port, or in this case it's basically a channel, 11.8 millimeters wide. Now where the channel cuts into the cavity, I found good results when the channel center is about 12 millimeters below the cavity center and 5 millimeters in from the edge of the cavity, with a cut depth of about 7 millimeters. Now with the inlet and outlet ports done, let's just take a recap. The fluid comes in through this inlet, spins around inside the cavity like this, and then exit here. Now if you look at the commercial pump tops, you'll notice that the transition between the cavity and the outlet channel is usually much smoother than what we're doing right here. That's because those are drilled from the side, which makes the machining more complicated and more expensive. But honestly, in real world use, you're not going to notice any difference in performance. This setup works perfectly fine. Now this side will be covered by the pump itself, so we'll need a lid for the other side. Now this lid will be 10 millimeters thick because we're cutting channels into it. We'll need both an inlet and an outlet channel. Each channel will be 11.8 millimeters wide. Now the inlet channel has to start 1 millimeter above the inlet port, and you'll see in a moment why. Now the outlet channel will be basically symmetrical to the base plate's outlet port, and both channels will be 5 millimeters deep. Now next, add O-ring grooves just like in the previous example, along with all of the fixing holes. And this is why the inlet channel is placed 1 millimeters away from the center of the inlet hole, to have enough material left between these two O-ring grooves. When placing the fixing holes, just make sure that they don't overlap with the pump cavity or any of the existing mounting holes. And finally, cut the 11.8 millimeter ports for the fittings. And that's it. You've got a very basic DDC pump top distro plate. Now before we move on to the D5 pump example, I want to quickly show you how to modify this distro plate into a small pump race combo. I'm first going to delete some of the existing features that we just made. We then need to move the pump cavity down and to the side. Now I found that the closest you can position it to the bottom and the side edges is about 36 millimeters. That works nicely since a standard DDC pump is roughly 62 by 62 millimeters. Now next we'll add a new outlet port to the base plate. This time, instead of routing it downwards, we'll have it exit to the side, still following the flow direction. And then just duplicate the outlet port over to the lid. Now let's turn the inlet channel into a small reservoir. Using the same offsets from the previous example, I'll draw the largest possible cavity that fits. Then I'll offset it and round the edges to a 5.9 millimeter radius, the same as the channels. Next I'll add the O-ring grooves and a few fixing holes. And just be careful not to cut into any existing holes or cavities while doing this. And just like that, you've got a small custom DDC distro. You can also add a few finishing touches by adding fillets along the edges and the corners. And by the way, I'll share all of the models used in these examples so you can download them for free. Now let's move on to the next example where we add a D5 pump to the distro plate. Now this example will be based on the custom distro plate I showed earlier in the video. We'll start with the base plate that will house the D5 pump. I'm making it 240 by 120 millimeters, and this time I'll make it 15 millimeters thick instead of 10 millimeters. And the reason for that is quite simple. The D5 pump is much larger than the DDC pump, and for it to work properly, its impeller needs a bigger and deeper cavity. Now for a D5 pump, it should be 49.5 millimeters in diameter and 12 millimeters deep. The D5 impeller also has a more rounded shape, so to help with the flow, we'll add a 4 millimeter radius to the inside edge of the cavity. You could take exact measurements of the impeller and model a perfect offset, but I've tried that before and honestly, it doesn't make that big of a difference, so this simpler method works just fine. And now just to add an inlet port, and this time it's going to be 10 millimeters, and it also has to go through the entire plate. Now for the outlet. Now just like the DDC pump, the D5 impeller also spins counterclockwise when viewed from the back. So the outlet channel needs to exit the cavity in that same direction. The outlet channel will also be 11.8 millimeters wide. It's the same size as a standard G1/4 inch thread. And we want the channel to intersect the cavity with its center 4 millimeters away from the cavity edge and 2 millimeters below the center line. Since the D5 cavity is deeper, we'll make this channel 8 millimeters deep. Now before we move on to making the lid with the channels cut into it, we first need to create a way to mount the D5 pump to the base plate. Unlike the DDC pump, which already comes with a built-in mounting block and an O-ring, the D5 doesn't, so we need to include this into our distro design. Now first, we'll cut an O-ring groove into the base plate to seal the pump. Now I don't use the stock O-ring that comes with the D5 pump. Instead, I use a custom one where I know the exact dimensions. Now the O-ring I'm using is 3 millimeters thick with an internal diameter of 54 millimeters and an external diameter of 60 millimeters, and it's designed to sit on top of the pump rather than around the edge. To fit the O-ring, we'll cut a groove measuring 53 millimeters by 61 millimeters with a depth of 2.4 millimeters. Now with that done, let's make the bracket that secures the pump to the plate. The bracket will be 78 by 78 millimeters, and we'll go ahead and add the mounting holes and the cavity for the pump body. It looks like we'll have enough clearance if we space the holes 45 millimeters from the center. Since these will be clearance holes for M4 screws, we'll make them 4.1 millimeters in diameter. Now the D5 pump body is usually 60 millimeters in diameter, so we'll make the cavity slightly larger, 61 millimeters. And the bracket will also be made out of 50 millimeters thick acrylic. Now this bracket will use the lip on the pump to press it firmly against the base plate. So we need to cut an additional cavity for that lip, and it will be 66 millimeters in diameter and we'll make it 10 millimeters deep. With that done, we just need to transfer the holes to the base plate, add some finishing touches, and then we're done with the bracket. Now let's move on to making the lid with the inlet and the outlet channels. Now I'm going to make the lid 10 millimeters thick, but you can use 50 millimeter acrylic if you prefer to match the rest of the build. The outlet channel will be symmetrical to the one in the base plate, and the inlet will be 11.8 millimeters wide and starting at the center of the inlet port. Next, we'll add some O-ring grooves and fastening holes, making sure everything clears properly. Add a small chamfer to all of the screw heads, and then finally cut the G1/4 inch ports, and there you have it, a complete D5 distro plate. Now this example is a simplified version and not exactly the same one as I showed you in the beginning of this video. So let's go ahead and modify this one to match that design. First, I'm going to delete a few features and start with the outlet port. I want this one to connect directly to a radiator, so I'm going to adjust the height slightly to line everything up. Next, I'll move over to the inlet side and expand it into a small reservoir. To make it even larger, I'll create a matching cavity on the base plate side as well. Now the last thing I want to do is to add a second channel that connects the radiator on this side. And to share the same mounting screws, I'll extend this section a bit to give it the space we need. Now once that's done, we just need to add some O-ring grooves back in, place the fixing holes, chamfer them for the screws, and then cut the inlet ports. And I'll maybe even add a full port while we're at it. And finally, I'll finish it all off with standard 120mm fan mounting holes and a few rounded corners. And just like that, you've got a fully custom D5 distro plate ready to go. With the distro design done, it's now time to get it ready for manufacturing. To have your design manufactured by PCBWay, or any other company for that fact, you need to export a step file for each individual part. Now, to export the step files is really simple. Just separate your distro plates into individual components and then save each one as a step file. Since some of the parts required threaded holes, you also need to include technical drawings that show where the thread should be and what type of thread you want. Now next, we'll create the drawings. You need a drawing for each part that has threads. The step file already contains most of the geometry details, so you don't need to supply all of the dimensions in the drawing. Instead, just include basic overall dimensions that the machinist can use to cross-reference the step file, and then clearly indicate any details like chamfers, fillets, holes and threads. To define the fixing holes and port threads, you need to specify them according to the machining operations. For example, with these chamfered through holes, start by defining the hole size and depth. In this case, the hole will be 4.1 mm in diameter and it goes all the way through the plate. Then, on the next line, define the chamfer. Here, the outer diameter of the chamfer is 8.5 mm and it's cut at a 90-degree angle. Now, instead of writing out this information for every single hole, and in this design there are 47 of them, you can simply define it once on the first line like this. Now, for the 5 full ports on this plate, each will be 11.8 mm in diameter and it goes all the way through the plate. Now, these holes will be threaded using a 1/4 inch British standard pipe thread, which is the standard thread type used for PC water cooling fittings, and this thread should be cut 5 mm deep. And finally, to finish off the drawing, make sure to indicate 2 key details: the material that the part will be made of and the file name of the corresponding step model. Now, with the drawing for the lid done, let's move on to the base plate. To make things clearer, I'll include both the front and back view of the plate, followed by adding all of the basic dimensions. There are 4 through holes, one in each corner, drilled to 4.1 mm in diameter. Now next, we'll define the 4 mounting holes for the pump bracket. Each of these will be drilled to 3.3 mm in diameter to a depth of 10 mm. And then threaded with a M4 thread with a 0.7 mm pitch to a depth of 8 mm. We will then define the 43 mounting holes on the front side, also drilled to 3.3 mm in diameter to the depth of 10 mm. And then also threaded with a M4 thread at 0.7 mm pitch to a depth of 8 mm. And by the way, 0.7 mm is the standard pitch for a M4 thread. And to finish up the drawing, don't forget to include the file name and the material specifications. Now technically, you don't need a drawing for the bracket, since it doesn't have any threads on it, but I usually make one anyway, because sometimes you just catch a small mistake while doing it. Now that all of the files are ready, we can finally upload them to PCBWay's website. So before we jump in, I've added a link to PCBWay's website down below. If you use my affiliated link, you'll get $5 credits towards your first project and will also help support the channel at no extra cost to you. To get started, head over to the CNC and 3D printing tab and click on CNC machining. Once you're there, upload your file. Make sure it's in step format. Then set your quantity and double check that your design units are in millimeters. Now next, under material, select PMMA. Now for the surface finish, I'm going with the standard finish. Just keep in mind you'll need to polish the parts yourself with this option. You can choose a higher end option like smooth machining, but that does increase the price quite a bit. Now, polishing your own parts might sound intimidating and time consuming, but don't worry, it's actually much easier and faster than you think. I'll show you exactly how to do it in the next step. Since this part has threads, make sure to upload your technical drawing as well, and select yes under the threads and tapped holes section. Everything else you can pretty much leave as is. Just add your product description and then repeat the same steps for the other 2 parts as well. Once that's done, scroll back to the top and now you see an estimated price and lead time, and you can go ahead and submit your request. Just keep in mind that this is only an estimate. An engineer will still review everything before you get your final confirmed price. Now within about 2 weeks, you'll receive your very own work of art from PCBWay. Now depending on the surface finish you selected during the ordering process, your parts might look a little bit different. As mentioned earlier, I went with the standard finish, which means I need to do some polishing and finishing work to get that glass-like shine. Now keep in mind, if you want PCBWay to polish it for you, they can, but it will cost quite a bit more. The good news is, polishing it yourself is actually pretty easy, and I'll show you exactly how. To polish acrylic, I use Meguiar's plastic polish, electric polisher with cutting and polishing foam pads, a microfiber cloth, and something soft to work on, like a towel. Start with the cutting pad. Apply some polish to both the pad and the parts, and buff all of the surfaces at around 1400 RPM. I avoid buffing the internal channels, since once the coolant is inside, you won't see any of the small scratches or machining marks anyway. Once you finish the first pass, repeat the process using the polishing pad for that final glossy finish. Now if you've got deeper machine marks or scratches, you can wet sand the parts before polishing. Depending on how severe they are, start with 800 grit sanding paper and work your way up to about 2500 grit sanding paper. For lighter scratches, rather start with 1000 grit instead. Now use a sanding block and some soapy water and sand the surfaces gently in straight, overlapping strokes, first up and down and then left to right. Repeat this process for each grit, sanding about 2 to 3 minutes per grit. Then once you're done, move on to the polishing process. After you have finished, it's a good idea to wash all of your parts with a bit of dish soap and warm water, just to remove any leftover residues that could interfere with your loop later on. Now it's time to make your custom O-rings and assemble your distro plate. To make your own O-rings, you'll need some 2mm O-ring cord, a utility knife and some good quality super glue. Now the first step is to determine the length of the cord. You could either measure it from your CAD model or simply place the cord into the O-ring groove like this. Be careful not to stretch it and just gently lay it into the groove. Once the two ends meet, make a small mark where they come together, about 2mm past where you want to make the final cut. Then remove the cord and using a sharp blade, make one clean, smooth cut to get a perfectly straight edge. You want it to be as clean and vertical as possible. Now test fit it again, and if it's too long, just trim it a little bit at a time until it fits perfectly. When you're happy with the length, add a tiny dab of super glue to the one end. Press the two ends together and hold them until the glue has set completely. If there's any excess glue, just wipe it off or carefully scrape it away with your knife. And there you go, a clean, seamless O-ring ready to be installed. Now to repeat the process for the other two O-rings as well. And now it's finally time to assemble the distro plate. And that's it. Once everything is cleaned and assembled, you've got yourself a fully custom distro plate designed and built from scratch. Now the only thing left to do is to add your fittings and to fill it up. Thank you for watching this video, and a huge thanks to PCBWay for making it all possible. Now I hope this video inspired you to go and design your own custom distro plate. Now, just a side note, all of the models shown in this video will be available to download for free, so just look for the links in the description below. Now, if you want to skip all of the design work, I'm going to share the project files for this exact distro plate on PCBWay's website, making it super easy to order your own. And I'll also link all of the materials used to assemble it. Now, if you enjoyed this video, please give it a like. And if you want to see more content like this, make sure you subscribe. Until next time, thank you for watching.